Everyone, welcome to Sangam Tutorials, Gubbi online classes for SSLC and Cbse 10th standard for mathematics and science. So in the last session of mathematics class, that is session 45, we had discussed regarding the polynomials. So regarding polynomials, we had understood the relationship between the zeros of the polynomial and the coefficients. So we did some 6 to 7 problems on it, and the next topic was you were given the sum of the roots and the product of the roots. Using the sum of the roots and product of the roots, we found out the required polynomial. So here in this class, we will be going with another very important problem, which is on cubic polynomial. So we all know that in a cubic polynomial there will be 3 zeros, at most 3 zeros. So it can also have 2 zeros, it can also have 1 zero, and no zeros also is possible. So when we are given 3 zeros, we have to verify that those 3 zeros are the zeros of the given polynomial and verify the relationship between the zeros and the coefficients. So with respect to the quadratic polynomial, the sum of the zeros formula was like this: alpha plus beta was minus b by a and alpha beta was c by a. So this was the relation between the zeros and the coefficients in a quadratic polynomial. So in case of a cubic polynomial, I had derived the relationship between the zeros and the coefficients of a cubic polynomial in the previous session. So just have to remind that. So alpha plus beta plus gamma is equal to minus b by a. So alpha beta plus beta gamma plus gamma alpha is c by a. And alpha into beta into gamma was minus d by a. I hope you remember this relationship. So these are the 3 relationship between the zeros and the coefficients of a cubic polynomial. So this is for quadratic polynomial and this is for cubic polynomial. Now we have a single one problem on a cubic polynomial concept. So here, verify that 3 minus 1, 1 by 3 are the zeros of a polynomial p of x, that is 3x cube minus 5x square minus 11x minus 3. So a cubic polynomial is given to you and we have to verify that 3 minus 1 and 1 by 3 are the zeros of that polynomial. We have to verify that and also verify the relation between the zeros and the coefficient. So in order to do the second part of the problem, we should be having the knowledge of this relationship, that is alpha plus beta plus gamma is minus b by a, alpha beta plus beta gamma plus gamma alpha is c by a, alpha into beta into gamma is minus d by a. So if you are going to verify the relation between zeros and coefficient, you have to use this. So therefore I have reminded this once. So let us solve the problem. Okay. So for you they are given a cubic polynomial, so let us go with that. So let p of x is equal to 3x cube minus 5x square minus 11x minus 3 is the given polynomial. So in the first part of the problem, we have to verify that 3 minus 1 and 1 by 3 are the zeros of this polynomial. So we have to verify that. So this is in the form of, let us compare with this the standard form. So therefore p of x is equal to ax square plus bx plus c, bx square plus cx plus d. So ax cube plus bx square plus cx plus d is the standard form of a cubic polynomial. So comparing the given polynomial with the standard form of the polynomial, write down the values of a, b, c and d. That's all. So therefore here a stands for 3, a is equal to 3, b is equal to minus 5, c is equal to, that is c is equal to minus 11, the coefficient of x, and d is equal to minus 3, that is the real constant. So d is minus 3. So now let us take the polynomial. P of x is equal to 3x cube minus 5x square minus 11x minus 3 is the given polynomial. So we have to check whether this is the zero of this polynomial, this is the zero of this polynomial or not, this is the zero of this polynomial or not. So if I want to check 3 is the zero of this polynomial or not, I have to substitute the value of 3 in place of x making P of x is equal to 0. That's the condition what I have discussed in the previous class. So P of x, put P of x, that is put x is equal to 3, that is the value of 3 here. So therefore P of x becomes 0, 0 is equal to that is 3, this 3, x is 3 here, so that becomes 3 cube minus 5 into 3 square minus 11 into 3 minus 3. So 3 cube is 27, 27 into 3, so we'll go like this. 3 into 3 into 3 is 27, 27 into 3, let's see whether it gets cancelled. 3 square is 9, 9 into 5 minus 11 into 3, that is 33 minus 3. So 0 is equal to 21, 617 minus 45 minus 33 minus 3, it is minus 36, minus 36. So 0 is equal to 81, sorry, so 81 minus 45 minus 36, 6 plus 5 is 11 and 4 plus 3 is 7 plus 1 8, so minus 81 plus 81 is cancelled, so 0 is equal to that is okay, is equal to RHS. So P of x has become equal to 0, or we can do one thing, we can maintain P of x here, P of x we can maintain, no problem, P of x. Here also P of x, so P of x is equal to 0. So if P of x becomes equal to 0 for any of the value what we have substituted in the polynomial, then that will be the 0 of the polynomial. So once again, you have a polynomial here, I have substituted the value of 3 to this polynomial, the value of the polynomial has become equal to 0. If the value of the polynomial is equal to 0, then the value what you have put into that polynomial is called the 0 of the polynomial. That's very simple. So let us go with the second part of that. So let us take the polynomial again. So P of x is equal to 3x cube minus 5x square minus 11x minus 3. So put x is equal to the second value, that is minus 1. So P of x is equal to 3 into minus 1 whole cube minus 5 into minus 1 whole square minus 11 into minus 1 minus 3. So P of x is equal to minus 1 whole cube is minus 1 into 3 is minus 3, minus 1 whole square is 1, minus 5 into 1 is minus 5, minus 11 into minus 1 is plus 11 minus 3. So P of x is equal to minus 3 minus 5 is minus 8, minus 8 minus 3 is minus 11, minus 11 plus 11 gets cancelled. So P of x is equal to 0 to 3. So for this polynomial P of x, when I substitute the value of x is equal to minus 1, then the value of the polynomial is become equal to 0. Therefore, minus 1 is the 0 of this polynomial. So let's check the another one. Let's take the polynomial. So P of x is equal to 3x cube minus 5x square minus 11x minus 3 is the given polynomial. 11x minus 3. So now let us put x is equal to minus 1 by 3, the third value what they are given, to verify whether it is a 0 or not. So x is equal to minus 1 by 3, so P of x is equal to 3 into, in the place of x we will substitute minus 1 by 3 whole cube minus 5 into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 3. So this we have successfully substituted. So P of x is equal to 3 into, so minus 1 by 3 whole cube is minus 1 by 3 into minus 1 by 3 into minus 1 by 3. So the minus sign appears 3 times, odd number of times, therefore it has negative sign. 1 by 3 into 1 by 3 into 1 by 3 is 1 by 27 minus 5 into minus 1 by 3 whole square. So the negative sign is getting multiplied even number of times, therefore it becomes positive. So it is 1 by 9. Minus into minus is plus, 11 into 1 is 11 by 3, and this is minus 3 by 1 for your convenience. So P of x is equal to 3 into, okay, we can cancel this, 3 ones are 3, 9s are, that becomes minus 1 by 9, and this becomes minus 5 ones are 5, 5 by 9 plus 11 by 3 and minus 3 by 1. So now let us take LCM for these two fractions and these two fractions separately. So it becomes easy. So P of x is equal to, for 9 and 9 LCM is 9, minus 1 minus 5, plus 3 and 1 LCM is 3, and that becomes 11 minus 3. Okay, 11 minus, 3 by 1 into 3 is 9, 11 minus 9. So P of x is equal to minus 1 minus 5 is minus 6 by 9 plus 11 minus 9 is 2 by 3. Okay, so here we can cancel here. 3 3s are 9, 3 minus 2s are is minus 6. So P of x is equal to minus 2 by 3 plus 2 by 3. So it gets cancelled. So P of x is equal to 0. So here, getting 0 at the end of substitution, and yes, we have got the answer. That's not the criteria here. By getting 0 at the end, when we substitute all the three values in the given polynomial, why we got zeros? That's the very important question here. So when we substituted the values of 3 in this polynomial, minus 1 in this polynomial, and minus 1 by 3 in this polynomial, we got the polynomial value equal to 0. So when you substitute a value to a polynomial and that polynomial value becomes 0, then the value what you are substituted to the polynomial are called the zeros of the polynomial. So therefore 3 comma minus 1 minus 1 by 3 are zeros of the polynomial, that is P of x. So this is the first part of the question we have answered, that is until here. So second part of the question is verify the relation between the zeros and coefficients. So we have to verify that. That's again the second part of the problem, right? Now, verify the relation between the zeros and the coefficients. So, in P of x is equal to 3x cube minus 5x square minus 11x minus 3. There are three zeros. Okay, just now we have verified alpha is equal to 3, beta is equal to minus 1, and gamma is equal to minus 1 by 3. These are the three zeros where we have verified them. So now we have to verify the relationship between zeros and coefficients. So therefore, alpha plus beta plus gamma is equal to, alpha plus beta plus gamma is equal to, can written as minus b by a. That is minus b by a. So alpha is that is 3 plus beta is minus 1 plus gamma is minus 1 by 3 is equal to minus b by a. So 3 plus into minus is minus 1, minus 1 by 3 is minus b by a. So 3 minus 1 is 2 minus 1 by 3. By 2 we can have 1 as the denominator, minus b by a. 1 and 3 LCM is 3. 2 by 1 into 3 is 6, minus 1 by 3 into 3 is 1. So it is 5 by 3, which is equal to minus b by a. So here, when you verify the given polynomial with the standard form, we had the values of ab and abc and d. So here a is equal to 3, b is equal to minus 5, c is equal to minus 11, and d is equal to minus 3. So therefore, minus b by a is 5 by 3. When you compare here, for minus b, that is minus of minus 5, that becomes plus 5, and a is 3, a is 3. So minus b by a is 5 by 3. So that's the relation between the three zeros. We will go with the second relation, that is alpha beta plus beta gamma plus gamma alpha is equal to c by a. Is the formula. So alpha is 3 into beta is minus 1 plus beta is minus 1 and gamma is minus 1 by 3 plus gamma is minus 1 by 3 into alpha is 3, which is equal to C by A. So 3 into minus 1 is minus 3, minus 1 into minus 1 by 3 is plus 1 by 3, and here minus 1 by 3 into 3 is here, 3 and 3 gets cancelled, so you are left over with minus 1 is equal to C by A. Okay, we will take the LCM here. For 1, 3 and 3 LCM is 3, minus 3 by 1 into 3 is minus 9, plus 1 by 3 into 3 is plus 1, minus 1 by 1 into 3 is minus 3. So that is C by A. So minus 9 minus 3 is 12, minus 12 plus 1, that becomes minus 11 by 3 is equal to C by A. So here you can see here the value of C in the polynomial is minus 11, that is minus 11, and A value, that is 3 here. So minus 11 by 3 is equal to C by A. We have verified the relationship between the zeros and the coefficients. So still more, we have another one relationship that goes like this. So alpha into beta into gamma is equal to minus D by A. This is one of the relationship. So alpha value is that is 3 into beta value is minus 1 into gamma value is minus 1 by 3 is equal to minus D by A. So 3 into minus 1 is minus 3 into minus 1 by 3. Minus 1 by 3. So 3 ones are 3, minus 1s are, that is equal to minus D by A. Minus 1 into minus 1 is 1 is equal to minus D by A. So here you can verify this. Minus D by A. Minus D is, here D is minus 3. So minus D is minus of minus 3. That becomes 3. And A is 3. So 3 by 3, answer is 1. So this is how it comes. So it's a very important, most important problem regarding the cubic polynomial. It's very, very important. Okay. Okay, we'll go with the next very important topic. This is division algorithm for polynomials. So we have to learn this. This is very, very important. Division algorithm for polynomials. Division algorithm for numbers you have studied in your previous classes. But in the polynomials chapter, you will be studying regarding the division algorithm for polynomials. So it is very important. Why it is important? Why it is required? Where it is required? At which point of divisions we require this division algorithm. Algorithm means a series of steps which are followed one after the other. A series of steps which are followed one after the other scientifically to prove the required thing. So we want to prove something. So to prove that, we do particular certain series of steps one by one to reach the desired result. So that is called as algorithm. So here division algorithm for polynomials we are going to do. So to understand this, let us go with an example. So imagine you are having a cubic polynomial. A cubic polynomial which is in the form of ax cube plus bx square plus cx plus d. That's a polynomial. You are having a cubic polynomial. So we know that for a cubic polynomial it has 3 zeros. So I will give you 1 zero of that particular cubic polynomial. We have 3 zeros. Out of 3 zeros I will give you 1 zero. And I will ask you to find out the other 2 zeros. So this is the situation where the division algorithm for polynomials is very much required. So how to go with that? Understand the situation once again. You have a cubic polynomial and we know that for a cubic polynomial we have 3 zeros. Among 3 zeros I will give you 1 0 and I will ask you to find out the other 2 zeros. Is that possible? Yes, it is 100% possible to find out the remaining zeros of a polynomial when one of the zero of the polynomial is given to you, including the polynomial. So for example, let us take this. I have a polynomial p of x, a cubic polynomial p of x. Any cubic polynomial can be taken. So x cube minus 2x square minus x minus 3. So this is a cubic polynomial. Okay, let us take 3x square. X cube minus 3x square minus x minus all minus is there plus 3. So it's a cubic polynomial. So for this cubic polynomial we have 3 zeros. We have 3 zeros. This is one of the zero, this is the second zero, and this is the third zero. We have all the 3 zeros for the cubic polynomial. Out of these 3 zeros, I will give you 1. That is, I will tell you, out of these 3 zeros, I will tell 1 is one of the zero of this polynomial. I will tell you that 1 is one of the zero of this polynomial. Find the other. So, if 1 is the polynomial, 1 is the zero of this polynomial, 100% this can be taken as x minus 1 is a zero of p of x. X minus 1 is a zero of p of x. So, if I tell you 1 is the zero of this polynomial, then x minus 1 is the zero of p of x. Because if x minus 1 is equal to 0, therefore x becomes equal to 1. So, when I give you 1 as the zero of this polynomial, you should take this expression as a zero of this polynomial. Because a polynomial is here, it's an algebraic expression. We are not going with numbers here. We are going with polynomials. So therefore, if 1 is the zero of this polynomial, we have to guess the corresponding polynomial of that. So 1 is the zero of this polynomial means x minus 1 is the zero of p of x. In that way you have to consider. If I tell you minus 1 is the zero of this polynomial, then you have to take it as x plus 1 is a zero of p of x. X plus 1 is a zero of p of x, because if you equate x plus 1 is equal to 0, x becomes equal to minus 1. So this is how it goes. If I tell you that 2 is a zero of this polynomial, for example, then you have to take it as x minus 2 is a zero of p of x. So because if x minus 2 is equated to 0, x minus 2 is equal to 0, then x becomes equal to 2. So this is how I will be telling you. 2 is a zero of this polynomial. So how this 2 comes? It comes out of here. That is x minus 2 is a zero of p of x. If I, for example, if I tell minus 5 is a zero of this polynomial, then you have to take it as x plus 5 is a zero of p of x. This is how you have to take. For example, if I tell you minus 1 by 2 is a zero of this polynomial, then you have to take it as x plus 1 by 2 is a zero of p of x. So this is, usually I find students getting confused, so I have given you more examples here. So in this problem, you are given a cubic polynomial and it has 3 zeros. For example, x, this is also x and this is also x. So there are 3 zeros. I will tell you that 1 is one of the zero of the polynomial. Then how you are going to take it? You are going to take x minus 1 is a zero of p of x. So this is a conclusion. So now, using the polynomial and one of its zero, how to find the other 2 zeros? How to find the other 2 zeros? So it's very simple. You have to take the polynomial. You have to take this polynomial. X minus 1 is the zero of the polynomial. Take the polynomial, that is x cube minus 3x square minus x plus 3 is the polynomial here. Inside this polynomial, we have 3 factors. Among those 3 factors, one of the factor is x minus 1. So that's the meaning. X cube minus 3x square minus x plus 3 is a polynomial, and this polynomial has 3 factors. The number has 3 factors. In the same manner, a polynomial has 3 factors. Among those 3 factors, one of the factor is x minus 1, and you have to find out the other 2 factors. So, in order to find out the other 2 factors out of this polynomial, we we have to divide this polynomial by the known one factor which is given to us, that is x minus 1. When you divide this polynomial by x minus 1, we get a quadratic polynomial over here. For example, x into x square is x cube, x into x square is x cube. So x cube I will write minus 1 into x square is minus x square. I will complete this. So sign changes. So this and this cancelled. Minus 3x square and plus 1x square is minus 2x square minus x plus 3. So x into what gives you minus 2x square, it is minus 2x. X into minus 2x is minus 2x square. Minus 1 into minus 2x is minus 3x. So this is plus and this is plus. It gets cancelled. Plus 3x minus 1x is 2x plus 3. So x into what gives you plus 2x? It is plus 2. X into plus 2 is plus 2x. Minus 1 into plus 2 is minus 2. Okay. So it gets cancelled. So remaining is some plus 5 remains. Let it be. So you have got a quadratic polynomial as a quotient. You have got it as a quotient. So for this cubic polynomial, you have 3 zeros. In the sense, you have 3 factors. Among those 3 factors, already one is given to you, that is x minus 1. So using this, you have to find out the other 2 factors. So in order to find out them, when you divide one of the, that is when you divide the polynomial by one of the factor, you are going to get the quotient as a quadratic polynomial. So inside this quadratic polynomial, you have the 2 factors of this cubic polynomial other than this. Those 2 remaining 2 factors are hidden inside this quadratic polynomial, right? So when you factorize this, that is x square minus 2x plus 2. When you factorize this by summation product method, what you have learned in your previous classes, you are going to get the other 2 factors. Because a quadratic polynomial has 2 zeros, in the sense it has 2 factors. So for this cubic polynomial, one factor is already given in the data. So when you factorize this quotient, when you divide this polynomial by one of the zero, those 2 factors of this quadratic polynomial are the other 2 factors of this cubic polynomial also. So these are the 2 factors. These are the 2 factors of the quadratic polynomial, and as well as these are the 2 factors of this cubic polynomial. So now this cubic polynomial has 2 plus 1, that is 3 factors. So in order to find out the other 2 factors of this cubic polynomial, we have to divide this polynomial by one of the 0. So therefore, we have to learn this division process. We have to learn the algorithm of division of polynomials. That is nothing but the topic. Division algorithm for polynomials. So why it is useful? It is useful to find the remaining zeros of a cubic polynomial or a quadratic polynomial, whatever it is, when one of the 0 is given to you. So this is the algorithm. Okay, we will go with an example. I hope you understood this. Let's take a beautiful example. P of x is equal to, I have a polynomial. For example, 2x square plus 3x plus 1 is a polynomial, and its one of the factor is x plus 2. Now let us consider this g of x. Consider that as g of x. That is another polynomial is g of x, that is x plus 2. Now let us divide this polynomial p of x by this polynomial, that is g of x, that is x plus 2. So here, when you divide this polynomial, it's a quadratic polynomial, and this is a that is a polynomial with degree 1, that's a monomial. So in the degree 1, this is a polynomial with degree 1 and this is a polynomial with degree 2. So while dividing one polynomial by another polynomial, the degree of higher polynomial can be divided by the degree of the lower polynomial. So here degree is more, here degree is less. So we can divide, we can carry the division process. So we will go with this now. We will go with the division process. Let us write the polynomial 2x square plus 3x plus 1. Let us take the quotient, that is divisor, that is x plus 2. X into what gives you 2x square? So it is 2x. X into 2x is 2x square. So let us write 2x square. Multiply this 2x by this 2 also. 2 into 2x is plus 4x. So subtract this polynomial from this. So sign changes. So plus 2x square minus 2x square cancels. Plus 3x minus 4x is minus 1x plus 1. So again, x into what gives you minus 1x, that is minus 1. So x into minus 1 is minus 1x, plus 2 into minus 1 is minus 2. So here we have to subtract this from this, so therefore sign changes. So minus 1x plus 1x cancels, plus 2 plus 1 is 3. So don't bother whether it is the remainder is 0 or not, don't bother about it. So here the division stops. The division process here stops because the degree of the remainder is less than the degree of the divisor. The degree of a constant is 1. The degree of a constant is 1 here, that is the degree of this constant is less than the degree of this divisor. So therefore the division process stops. So here this is the divisor. This is the divisor. This is the quotient we have got. This is the quotient, and this is what which is getting divided is called dividend. Dividend, and this is the thing what is left out is the remainder. So here there is a relationship between this divisor, dividend, quotient, and remainder. When you divide a polynomial by another polynomial, the polynomial which is going to get divided is called as the dividend, which divides is called the divisor. How many times it divides is called the quotient, and during the division process, what is the leftover thing is the remainder. So let us write the relationship. Dividend is equal to divisor into quotient, plus remainder. Divisor into quotient plus remainder. So dividend is 2x square plus 3x plus 1, which is equal to divisor, that is x plus 2 into quotient. Quotient is 2x minus 1, that is 2x minus 1 plus remainder, that is 3. So 2x square plus 3x plus 1 is equal to x into 2x is 2x square, x into minus 1 is minus x, plus 2 into plus 2x is plus 4x, plus 2 into minus 1 is plus minus 2 and plus 3. So 2x square plus 3x plus 1 is equal to 2x square minus x plus 4x is plus 3x, minus 1 plus 3 is plus 1. So here we can see that the LHS is equal to, it has become equal to RHS. So this relationship what we have here is dividend is equal to divisor into quotient plus remainder. This is called the division algorithm for polynomials. So it is very much required to find the zeros of a required polynomial. So some polynomial is given, maybe a cubic polynomial, 1 zero will be given to you and asked to find out the other 2 zeros. So in that process of finding the required other 2 zeros, we need this division algorithm for polynomials. So you are given with a quadratic polynomial, you will be given 1 zero and you will be asked to find out the other zero. Then also we can go with the other zero for this. For example, another very important thing is if you divide any polynomial by another polynomial and if you get the remainder as 0, exactly 0 here, then we say that this is a factor of this. This is a factor of this. When you divide this polynomial by this polynomial and you do not get the remainder as 0, then we say that this is not a factor of this. That's very simple. Let us go with another example. I will show you another example. A simple example we will take regarding a cubic polynomial. So P of x is equal to, let us take the example of a cubic polynomial. So 3x cube plus x square. So as it's a cubic polynomial, the highest degree of the polynomial should be 3. So plus 2x plus 5 is the cubic polynomial. So we will divide this given cubic polynomial by a quadratic polynomial. So that g of x is equal to x square plus x plus 1. So this is a cubic polynomial and this is a quadratic polynomial. Let us divide this by this and we will apply the division algorithm for polynomials. So let us start the process. So 3x cube plus x square plus 2x plus 5 is the given polynomial. So x square plus x plus 1 is the divisor. So x square into what gives you 3x cube? It is 3x. X square into 3x is 3x cube plus x into plus 3x is plus 3x square plus 1 into plus 3x is plus 3x. So once you multiply by the first number, same number should be multiplied by the remaining terms also. So you have to subtract this from this. So sign changes. So it cancels. Plus 1x square minus 3x square is minus 2x square. Minus 3x plus 2x is minus x and plus 5. Remaining thing is that. So now x square into what gives you minus 2x square? It is minus 2. X square into minus 2 is minus 2x square plus x into minus 2 is minus 2x plus 1 into minus 2 is minus 2. Okay, we'll subtract this from this. So sign changes. Minus becomes plus and this minus becomes plus. We'll cancel the first terms. Plus 2x minus 1x is x plus 2 plus 5, that is plus 7. So here when you compare the degree of this first term with the degree of the divisor, the degree of the remainder has become less than the degree of the divisor. Therefore the division process stops here. So let us verify the division algorithm for polynomials. So P of x, this is P of x and we will call it as g of x. P of x is equal to g of x into, let us call it as q of x plus, let us call it as r of x. Let us call it as r of x. So dividend is equal to divisor into quotient plus remainder. So P of x is 3x cubed plus x square plus 2x plus 5 is equal to g of x is x square plus x plus 1 into q of x is 3x minus 2 plus r of x is x plus 7. So 3x cube plus x square plus 2x plus 5 is equal to x square into 3x is 3x cube, x square into minus 2 is minus 2x square plus x into plus 3x is plus 3x square plus x into minus 2 is minus 2x plus 1 into 3x is plus 3x plus 1 into minus 2 is minus 2 plus this one, that is x plus 7. So 3x cube plus x square plus 2x plus 5 is equal to 3x cube minus 2x square plus 3x square is plus x square minus 2x plus 3x is plus x and plus x is plus 2x and plus 7. Plus 7 minus 2, that becomes plus 5. So the same thing repeats here. So this becomes LHS is equal to RHS. So this is how we have verified the division algorithm for polynomials. So this is the relation. This P of x is equal to g of x into q of x plus r of x is called as the relationship between the division, the divisor, dividend, divisor, quotient and remainder. So this is the relationship and this is the algorithm which is required to understand or to take out the relationship between the four things, that is dividend, divisor, quotient and remainder. So if you want these two, you have to divide this by following an algorithm, and the relations between this and this is given by this relationship, that is division algorithm for polynomials. So this will be used to find out the required number of zeros of any given polynomial, right? So in this class, I hope you enjoyed it. So this is very important class. You have to learn very well this process. Most of the students fail in this. They get confused, sir, how to go with this. So this requires a little bit practice. That's all. In the coming session, I will be doing more number of problems on it. So practice the problems the day itself. I will give you some of the problems for practice so that you can do well. You can take a grip on them. So please remember at this instance, I will take this opportunity to remind you that June 10th will be the last date for the payment of the first installment of fees. So please make your time to send it through the banking system, or that is Google Pay or whatever it is. And if you are free to come to the center, you can please come over and pay the fees, right? So stay home, stay safe, keep learning. Thank you.